It is some group. So it's no longer individually identifiable. How would you do this? Well, instead of the birth date, maybe we just give the year. Instead of the zip code, maybe we only give the first few digits of the zip code. We generalize the data. Maybe instead of gender, we don't give gender. We suppress the data. There's things you do to make the data more general. There's some limitations to it. So here's an example of a two anonymous data set. So we can see, for example, we have two people with an advanced degree. Maybe one of them has a master's, one of them has a PhD. That would allow us to distinguish between them. But this just says they both have an advanced degree, and they're in zip code 4790 something, and age is in the range 40 to 50. But can anybody see a problem with this? Say we're interested in detecting our enemies here. We want to know if someone has been proclaimed to be one of our enemies. But you really don't want to be in this database and announced as an enemy. Well, it's anonymous, so that shouldn't be a problem. Does anyone see the problem with this?
You don't have 30 to 40.
Well, it's worse than that, even with just these number of people. Say I know that someone is, I've got an individual and I know they're 48 years old, they have an advanced degree, and they live in Bloomington, 4740 something. Do I know if they're an enemy or not from this data set?
It's a good chance.
Well, I only have two individuals that meet that criteria. So it's anonymous. I don't know which individual that is. But if you look over here, both those individuals have the same criteria for the sensitive variable. So we've still revealed the sensitive information about this individual, even though we have met the anonymity requirements. So that's one problem with anonymity, is it doesn't really take into account that there may be some sensitivity to data and that's what you're really trying to protect. Oh, there. So there's been another approach to this. Actually, most recently you'll hear people talk about L-diversity, although originally and independently it was developed as discernibility. The idea behind this L-diversity and discernibility is you start with k-anonymity, but then you also require that within any k-anonymous block, the sensitive values have to be well represented. Where well represented is this parameter L. It's L-diverse if there is this parameter L level of diversity or discrepancies among what we might think ascribed to an individual. So one example would be we could use entropy within that block. What is the entropy? Because one problem is you might say, well, what does that diversity mean? Say if I were to look at gender of the incoming freshman class in computer science, and I insisted that to have this anonymity factor, that any block had to have an even distribution between men and women. Am I going to be able to do a good job of that? Well, it's going to turn out to be very difficult to do because we tend to have a very gender-biased sample that we're drawing from. So one way to handle this is to say that within any block, the entropy among those sensitive values must be comparable to larger blocks. And so using concepts like this, and I would encourage you to read actually a just out, although I list this as '05, there is a IEEE Transactions on Knowledge and Data Engineering journal article out by the folks at Cornell that goes into considerably more detail on this and really talks about how you can use this to ensure some level of privacy. Okay. We can go even farther in some of these, and this is some, well, folks at Stanford, Microsoft Research, Cynthia Dvork, Chawla, Smith, I don't remember the M and W, exactly what they stand for off the top of my head. But this takes almost a geometric view or a numeric view to it, that it's not just about a specific fixed database. What we're talking now is that a point should not be isolated in space, that there should be some uncertainty. And the idea behind this CT isolation concept is that we have some query that will retrieve us a set of points. And the query CT isolates a point if a space that is centered on the query and whose width is C times the distance between the query and this point contains fewer than T points. So let me quickly draw this up if we can. How do I go about switching to the overhead camera? Is there a way I can get this?
Yeah, it's going.
Okay, so if we switch to the overhead camera and take a quick look, we may have a query point here. So here's Q. Over here is a point, and just to make it simple, we'll use C equal 2. So here's a point Y. What we do is we take this distance, go out C beyond it, look at a ball around this space, and then count the number of other points. If there are T points within this space, then we're deemed to have met this requirement. If there are fewer than T, then we've isolated this point. Well, where this definition starts to get interesting is if you say, what are the possible queries we could ask about the data set? And does CT isolation fail for every combination of these queries? In other words, is there no way that we can isolate that point? If so, we have our level of anonymity. So, again, there are some real challenges in this. I'm not going to go into the details on this because it is a very challenging, very challenging paper, difficult to, when you get into the real details of how do you prove this across a space of queries. Okay. But a lot of this, this begs a very big question. How do we set these parameters? I've said K anonymity, L diversity. There's all these open letters and CT. How do we come up with some meaningful measures? It turns out it's kind of interesting. What does HIPAA, the U.S. healthcare rules, say? Well, what they say is there is no reasonable basis to believe that the information can be used to identify an individual. What does identify an individual? If I can say, here's a medical record, and I know it belongs to either Faribor's or Randy, but I have no idea which one. But since you can't tell which one, it's not traced to an individual, I'm going to take this medical record and just pass it around the room. How many of you would feel that I am not violating someone's privacy? How many of you would feel that I am violating privacy by doing this?